Hello, hello. Okay, so last section in chapter one, which is great. This week, first week, I know must be weird, you guys, but as always, just stay in touch, keep communicating with me, and we'll make the best of it. Okay, so we're going to do horizontal and vertical asymptotes here, and you learned about horizontal asymptotes and vertical asymptotes in pre-calculus, and calculus really just makes it a lot easier. So in calculus, what we're going to do is we're going to think about just overall, function knowledge here. And so you guys probably would look at this and say, look, there seems to be a horizontal asymptote, and it's equal to y. I'm sorry, y equals 0. So it's basically the x-axis here. Well, how did you guys determine that? Well, what you did is you looked, and it seems like this function here comes down towards 0 but never touches it, right? And that's kind of what pre-calculus talked about. They said, well, it never crosses a horizontal asymptote. That's not true. Okay, you can cross over a horizontal asymptote. There are functions that exist that look like this, and then they come back and they approach the x-axis, and this way they approach the x-axis. And so you still would have this line, right, y equals 0 as your horizontal asymptote, and you did cross over it. So be careful there. So in calculus, what we do is we say, what happens as the function gets big? Well, that's a limit. What's the limit as x gets ridiculously big of the function? Okay, and if you evaluate that limit and you get a number, right, that is your horizontal asymptote. Okay, similarly, going this way, what happens as the function gets really small? And if as the function gets really far to the left, or as x approaches negative infinity, you approach this value L, that's a horizontal asymptote. Okay, and so to formalize that, again, what we have right up here is the definition of a horizontal asymptote. You need to take the limit of the function as you go to infinity and as you go to negative infinity and analyze what's happening. Okay, the numbers, right? If you get a number, right, your horizontal asymptote would be the y equals that b value, and there could be more than one. So maybe two. Okay, so be careful. All right, so let's just do an example here. So find the horizontal asymptote, definition-based calculus students. If you guys follow this from the beginning with me, we underline definitions, we memorize them, and when we see it on the AP exam, it's easy. So the definition of a horizontal asymptote is the limit as x approaches both positive and negative infinity of the function. So you know that definition, okay? And then we're gonna plug that in and find the values here. So let's find first the limit as x approaches positive infinity of this function. First rule of limits, things don't change. First rule, direct substitution. Figure out what happens when you plug in infinity. 2 plus 1 over infinity. This approaches a value of 0. And so we say 2 plus 0 is approximately 2, or a value of 2. Okay. The second thing you have to do to find a horizontal asymptote is take the limit as x gets ridiculously small, or negative infinity. Okay. And as you approach a value of negative infinity, you still do direct substitution and figure out what that is. This is still a value of 0. If you're confused on that, you could always go back to the lesson before, right? We talked about 1 over a huge number acts like 0, even when it's negative. Okay, and you get a value of 2. So in this case, we only got one value, 2 on each of them. So we would say, therefore, our horizontal asymptote is the line y equals 2. Okay. Now there is a pre-calculus method to do this. It says, oh, we'll compare the degree of the top to the degree of the bottom. And if the degrees are the same, then it's a ratio of the coefficients. That's great, except for we don't always have polynomials over polynomials. You have square root functions. You have a combination of a rational function with something else. So this calculus method is much easier and much more powerful. Okay. All right, same thing here. I guess as a pause here, you guys would always want to use technology, right? This is an AP standard. Use technology to verify that what you did isn't crazy. Okay, so verify that when you analyze 2 plus 1 over x as a function, you zoom 6 that, right? Which is not what we're going for, because our definition is x goes to infinity, right? But even with that graph, only out here at a value of 10, right? As you come over here to the right, you can clearly see that this thing is coming down and approaching a value of 2, right? Which is the definition of a horizontal asymptote. Okay. All right, so let's do example B here. Same thing. We're going to evaluate the limit of this function as x gets extremely large and see what happens. Well, we're going to do infinite limits, which we just talked about. We're looking at infinity over the square root of infinity squared plus 1. Well, this limits at infinity. This 1 is not going to change, right? The value of infinity squared. I mean, think about a gazillion squared and then add 1 to it. You're still at a gazillion squared. This is the main factor. And so in your brain, you're thinking about, well, what does this act like? Well, the square root of infinity squared, simple algebra, right? We're thinking about infinity over infinity. So, we do all this and we get down to a value of 1, okay? And, the question becomes, is this legal? It is. And, to do this limit at infinity with some complicated algebra is beyond the scope of this class. I think I said last lesson that I'll do some side note lesson on it. That won't be required, but I think it's worth doing. Or maybe, I'll save this for a Zoom call. Okay. All right. The other one we're going to evaluate is the limit at negative infinity. And so, negatives just make things more complicated. But remember, in algebra, simple algebra, which is not simple, I say that a lot, but this is where everyone messes up. When you plug in a value for a variable, it has to be plugged in parentheses, right? Back in the day, algebra 1, f of x equals x squared plus 1. If you're trying to evaluate f of negative 2, okay, you have to put that numerical value in parentheses first before you square it in order to get the correct answer of negative 5. Because if you do this, right, which would be bad, and you said, well, that's negative 2 squared plus 1. Well, you're not going to get the right answer, right? You guys know that. Negative 2 squared plus 1. Simple PEMDAS is going to square that first to get 4, make it negative, and then add 1 to get negative 3, which is obviously different than the correct answer, which is plugging it in parentheses. Okay, so fill in all the gaps and holes in your algebra here. This is bad. Okay, so up here, we're still acting like it's infinity over the square root of negative infinity squared. Well, negative infinity squared, okay, we talked about that. It's negative infinity times negative infinity, which would be positive infinity squared. So this, again, is going to act like infinity over infinity, or 1. Okay, and so following this line of thought here, knowing that a negative squared would be positive, then simplifying that to that, it acts like 1. We're saying, therefore, we think our horizontal asymptotes should be the line y equals 1. Okay, and let's check out that function. So we go back in here, alpha y equals enter. Okay, is how you get that pretty print with the fraction. And you're going to put x over the square root of x squared, okay, plus 1. And you're going to zoom 6 that guy. And we're trying to figure out horizontal asymptotes, which are as x goes to infinity and negative infinity. Okay, and it seems like something happened here because we didn't get negative 1. But it seems like as we go to the right, it's 1. And as we go to the left, it's negative 1. Okay, and we made a simple algebra error here. Maybe you guys caught it as I was going along. But you guys see how I plugged in negative infinity right there? Which is good, but what happened here? I forgot my negative. Okay, so if you carry that through, you end up getting your negative 1, which is correct. So sorry about the algebra. But this is, look, I've been doing this for decades, guys, and it happens very easily. So using technology to verify answers is great because we caught our error here. What is the horizontal asymptote? It's both 1 and negative 1, right? Because we forgot to directly substitute in that negative. Okay? All right. So in addition to horizontal asymptotes, we have vertical asymptotes. Okay? And, reading this type of theorem, right, or definition is not necessarily intuitive. So I'll start real quick with something that you know to be true. Okay, so I think you guys hopefully are all very familiar with vertical asymptotes. If I was to give you guys in pre-calculus a function that was, let's say, x over x minus 2, okay? This denominator, this is bad, if x equals 2, right? Because if x equals 2, the function value of 2 is 2 over 2 minus 2, which is 2 over 0, which is undefined, which means as I come to that value of 2, I cannot define the function value, so I can't put a dot down, okay? And if you guys looked at this graph in pre-calculus, right, and you put in x over x minus 2, hopefully your pre-calc teacher, I don't know who it was because I'm just getting to know them all, but maybe it was Flisher, maybe it was someone else, Hubuck, I don't know. All right, so if you graph this guy, zoom 6 it, and you check this out, you will verify that you do have that vertical asymptote. Okay, so you should have that knowledge from pre-calculus. You should look at a function like this and say, hey, my answer is vertical asymptote happens at x equals 2. Okay, and then calculus, right? What I'm going to expect you guys to do is to verify, okay, verify that that is true. How do you do that with calculus? Well, think about this. What happens if I take the limit as x approaches 2 from the left? Okay, now we have the graph that we looked at, but we're going to assume we don't know, but let's evaluate the limit as x gets close to that x value from the left, okay? And direct substitution, right? We're coming in towards 2 from the left-hand side. So like 1.99, you're thinking about 1.99 divided by 1.99 minus 2, okay? Which is 1.99 over, remember, this is going to be a negative tiny number. Okay, and if you have a number that's divided by a negative tiny number, it goes in there a ton, right? It's a very large number and it's negative because of positive divided by negative. So we get negative infinity as our answer. Well, what you guys just said is as you come in towards 2, you are going down to negative infinity. If you did the limit as x approaches 2 from the right, if you plug in 2.01, right, 2.01 minus 2, all of a sudden you have the same argument, 2.01 over, this is going to be a tiny number, and it's positive. So this is going to give us positive infinity. And so you just said as you come in on the function this way, as you get close to 2, I'm going up to positive infinity. Well, look. Okay, so we just used calculus. We used pre-calculus to say, look, at 2, this thing's undefined. What happens as I come in from the left and what happens as I come in from the right? That has verified that that is a vertical asymptote. Okay. All right. So looking back at this, okay, you can see why this fact, you have to know this from pre-calc, or you don't know where to start. That's where students always get lost. Okay. So once you decide that something is a vertical asymptote, you're verifying it by taking the limit as you get close to that value from the right and from the left. Okay. All right. This is a typo here. The line x equals a is a vertical asymptote. This should be a little a here, and this should be a little a here, and I will go on and fix those notes. Okay. All right. So look, from pre-calc, you guys should know. When you look at that function, you can tell me, look, that vertical asymptote is the line x equals 0, right? Because when I plug in 0 there, I get undefined. Now, the calculus part of this is to verify that that is true. And how do I do that? All you have to do, you guys, is take the limit as x approaches 0. I don't care whether you go from the right or from the left. Choose one of them and show me that the answer is either positive or negative infinity. Okay, if you go towards 0 from the right, you get 1 over some tiny number squared, which is 1 over tiny. And yes, you can write that on my tests if you have to. And 1 over tiny is positive infinity. And you have verified that as you get close to 0, you're going up for forever. And that's what a vertical asymptote is. Okay, last one here, pre-calc knowledge. Pre-calc tells me there is a vertical asymptote at x equals 2. Okay, calculus to verify. And what do? You take the limit as x gets close to that value from the right or from the left. I don't care. And you better get infinity or negative infinity. If you go towards 2 from the right, you're at 1 over some small number that's bigger than 2 minus 2, which is 1 over a tiny number, which is positive infinity, and you have verified. Okay? All right, so to finish up the chapter, we just talked about how you find a horizontal asymptote. By definition, you have to check 2 things. You have to write this on a test. You have to write this. Evaluate what those are, and whatever numbers they are, that's your horizontal. Maybe you have just 1 because they're both 2. Maybe you have 1 of each. Okay, for a vertical asymptote, you have to identify what it is by knowledge from a previous course and then verify it with calculus, which is just taking the limit as you get close there from the right or the left, and you have to get infinity or negative infinity. Okay. All right, guys, week 1 done. I'm proud of you. I don't know you guys well enough yet, but we're gonna keep it positive. Talk to you later.